Approaching. Uh, Before you start recording, kindly at least let me know once so my what I'm saying is not cut in half. So I was saying today is going to be a bit different. I won't be implementing line by line code, even though I can. But it's better since there's a little bit complexity to my solution. I know there's a better solution with, I believe, a left and right pointer. But for now, what I'm going to do is I'm going to explain the approach I've taken to solve this problem and the thought process I had to go through. A lot of times we're jumping directly to how efficient the code is, how the code is jumping back and forth, and what is it skipping, what is it including. But I think to be able to explain your thought process is also a very important aspect of interviewing or trying to explain your problem, a solution to your problem. Why I'm saying that is because recently we had a demonstration by one of our new engineers who is an experienced resource, but this individual, he implemented this circuit breaker pattern in a couple of our microservices, and he did a great job actually. He worked really, really hard to implement circuit breaker. It's new in our application, even though other applications within the same department are using circuit breaker. But this person, when he started giving the demo, he was not able to explain his thoughts. In fact, he was so used to reading and using the terminologies of system design, such as robustness, reliability, scalability, that he kept jumping back and forth between those terminologies, and he was not able to vocalize his own thoughts and ideas and the thought process he had gone through. So it's very important to number one, do go through that thought process, uh, be a storyteller. Number two is that allow when someone is telling you it as a story, allow them to finish their conveying their ideas, and then you can interrupt or you can intervene whenever needed. So conclusion, what happened to the burger thing is that even though the idea is a working idea, it's a working solution, a lot of people end up, I think not a lot, but I think most of us end up being uh, most of it end up sleeping during that session. And even though it's a good idea, but no one actually bought it because I don't think people are able to even understand that. Anyways, we'll start with the name of Allah. Thank you all for joining. I've already taken 4 minutes trying to explain. Uh, so I'll just go ahead and start with the question. Okay, so the question we are going to solve is three-sum question. We have done a two-sum question where we are required to find those two elements, A and B, for example, that if you take their sum, they equal to target, a number that is marked as target. But in this case, they're saying that you need to find three numbers, I, J, and K supposedly, that if you add them, you get answers as zero. You get target as zero. So here you're given target as zero, and you're asked to find three elements if you're given an array. Okay, we are not restricting ourselves to strictly increasing or strictly decreasing. In fact, what we're doing is we're looking at a completely random array where we have positives and negatives, right? So in that case, the best we can do is, and this is a fact about the threesome problem, that there has not been yet discovered a solution that is better than O of n square. And I'll tell you the reason for it. Okay, first let's read the problem and try to understand what is actually required here. I'll magnify this a little bit so it's easy for you guys to read, and then I can readjust it if needed. So, given an integer array nums, return all triplets. They're asking for all triplets such that your nums of I, nums of j, and nums of k, um, this will be your triplet. Okay, if you pay attention to this, this is an array, and then you have subarrays. Actually, you won't know this um, until you. Okay, anyways, we'll move. I'll be able to explain it later, I guess. So you are being asked for triplets. This is a triplet. This is an array, okay? This is an array where you have I, J, and K as three numbers. When you add them, When you add them, you get 0. Okay. But then there is a condition that I is not equal to j, I is not equal to k, and j is not equal to k. Basically, what they're saying is that none of these numbers are equal to each other. Okay. But these are not numbers. These are basically indices. Okay. When you're saying nums of j, you're talking about the number. But when you say j, I, and k, they're just indices. So basically, what they're saying is that you can have two numbers that are same. Okay. In these three triplets, numbers can be same, but they have to be on different, they have to be on, excuse me, just, but they have to be on separate indices. Okay. So that's what you have to figure out. Okay, and that when you take the number upon those I, J, and K, when you add them, you get a 0. Any questions so far? None? Okay, we'll move forward. So we're being asked about three things for now. We haven't read this. First thing is that you have to have numbers on separate indices. Okay, one, two, and three, and then you have to add them to get 0. Okay, and notice that solution set must not contain duplicate triplets. Okay. What does a solution set means in this context? The context of this question specifically is that when you return the answer, it has to be a list of lists. Okay. So this will be your triplet and this will be your original list. So your original list will contain multiple triplets. It can have a single triplet. Okay. It'll look something like this: 0, 1, 2. Okay. And 2, 4, 6, for example. So it's a list of lists, nested list, if you will. So that's how we have to return the answers. When they're saying, you notice the solution set must not contain duplicate triplets. So if you are getting something like an array of arrays where you have -1, -1, 2, and then -1, -1, 2, okay? Or maybe even if it's something like -1 to -1, this is the same thing because you're adding, right? So you're going to get same answer from these. The answer of this A triplet, B triplet, and C triplet, they're going to be the same. They're not going to be different. So you cannot have these duplicates in any of these cases. This and this is also same, A and C are. So you can have only one instance of this. You want to return distinct duplicates of distinct triplets of the answer of this input array. Okay, so all right. So notice that the solution set must not contain duplicate triplets. We have already discussed this. Let's look at a few examples and try to wrap this up as quick as possible. So this is an example. They return triplets. Okay, they're not equal. They're distinct indices. Okay, and they have computed the entire thing. Finally, they're saying one more thing is that it doesn't matter which order you're returning your triplet in. The order does not matter. The only thing matters is you should not have duplicate triplets, and the elements inside the triplets have to fall on distinct indices. Okay, so you have to keep these things in mind. It doesn't matter if you return. It does not matter for them if you return if you put this one at 0 index and this one at 1, or this one at 0 and this triplet at 1. Okay, all right. So okay, in case where you have zeros, okay, you need to return zeros in this case. Okay, so if you have zeros, you're always going to return um, no matter what you do with zeros, 0 minus 0 minus 0, or 0 plus 0 minus 0, it doesn't matter. It's always going to return 0. So if you have like 100,000 zeros inside that array, you only need to return this. Why? Because you don't want to have a situation where, I'll give you an example here. I have a submission that I did and where my time limit exceeded right here. if you look at this input, if you start even converting it like these in triplets, okay, you have a lot of duplicates, right? You have a lot of duplicates. You don't have duplicates, you just return one, okay? So in that case, you have to just return 0, 0, 0. Okay, now let's move back to our okay, let's move back to our question. Where is it code? Okay, so this is the question. The constraints are um, nums.length, which means the length of your array is less than or equal to 3000. You can have these many elements inside the array between three. At least it needs to have three for you to consider it as a, because you're looking for triplets as a proper input. And negative 10 power 5, your numbers, individual numbers could be negative 10 raised to power 5 to positive 10 raised to power 5, which I believe is 100,000. Yes. Okay. Um, what was my approach to solve this problem was it's not space efficient, but time complexity wise, it does achieve O of n squared. So how did I think about this? First of all, in order for me to get um, zero from three numbers, three distinct numbers, okay, 1, 2, 3, -1, -1, and 2. The reason why this does not give me 0 is because I cannot find two numbers that if I add, the third number will be the negative of the sum. But in this case, if I add -1, -1 is -2, and +2 is the opposite of it. Therefore, it will compute to 0. So in order for me to compute to 0, I need to have a negative number and a positive number. But what if I have three numbers? Then I have to make sure that two numbers, if I add them, they become opposite of the third number, sign-wise, okay? The type-wise, it becomes the opposite of the third number. And that's how I'm going to find my triplets, is that I'm going to find all these sums, and then I'm going to look for the third number that is the opposite of that sum, okay? And how I thought about doing that is, first of all, in order for me to compute all the sums, there's no other way but to do the nested loop. For each element, I explore every other element. I add them, I plus j, and then I keep moving my I forward, and then restart j from the next index forth, and keep exploring the entire array until I'm done exploring all these sums. And every time I'm checking the sum, I can do one more thing, is that I can take this array, store it in a hash map. Okay, store it in a hash map. -1, -4. I can store it inside a hash map, because whenever I want to access any element from the hash map, the time complexity of accessing the operation required to access any element inside the hash map is just O of 1. The only problem is running I for j, it gives me O of n squared. So O of n squared plus O of 1, we consider this worst time complexity. Now, what should be my method for finding the sum and the opposite of it? The approach I'm taking is, first of all, if I've computed a sum, -1 plus 0, and in hash map I have -1, 0, 1, 2, and -4. Let's consider this a hash map, okay, for now. Let's consider this array that we have been given as a hash map. Okay, if I'm computing this, -1 plus 0, what do I get? -1. So now I will look in the hash map if there is a key that is +1. If I can find +1, and I have to check if the +1 is not as the same index as these. Let's say the index for this one is 0 and this is 1. If on the third index I was able to find an element that if I add to the sum of it, I get 0, then yes, I've accomplished my one triplet. Therefore, I can take the element from the hash map, I and j, and put it inside the array list, I, j, and get from the map. Okay, so that's how I can keep creating my triplets. And by making sure that I'm not getting duplicates and all that, I can finally add them to a larger list, to a parent list. Um, and this will be my triplet, and then return the answer. So that's the approach that I'm going to take for solving this problem. Okay, I'll go through the code. I'm not going to write this so that other people can get opportunity to present questions on their end if they wish to.
जी सर, मोहम्मद बुराना अपना क्वेश्चन कर सकते हैं।
Sir, what about the duplicates number? Like we have 2 minus 1 in the nums array, and how we store them in hash map?
Good question. Yeah, I forgot to tell you about this. So this was a challenge I was hitting, that if I'm storing it in a single hash map, then in that case, I'm losing elements because hash map will not allow me to store duplicate numbers, right? In that case, what I'm doing is, um, actually, it's a step later, but I'm going to tell you. I'm using two hash maps. Okay. First of all, I'm going to store the unique elements in one hash map, and if there's a duplicate, I store the duplicate in the duplicate hash map, right? In a way where in the unique map, if I found, for example, -1, I put -1 as key, and then initiate an array list as a key and value, right? In that array list, in that array list, I let's say I found this on index 0. I map it to index 0. Okay. If I again find it 0, 1, 2, 3, 4, I map 4 here, but I don't add it again. Okay. Where do I add it? I add it in the duplicate map, that this is a duplicate number that I found. Okay. And where will I use this is when later down the line, when I want to find that if -1 has not appeared, if there's not an index, let's say if I find 0 and 1, okay? So if I've stored indices for this, the indices should not match with this index, okay? If I'm not recomputing this, then I'm good. Once we get there, you're going to understand what I've done. And from there onwards, we can clarify any confusion. But my idea was, if one map cannot store duplicates, the second time the duplicate is going to find it should store in another hash map. Okay. But what if there's a third one? So in that case, we cannot just keep creating hash maps. It's going to be very space consuming. So what we do is we note down the indices where a number has reoccurred, and then we use those indices for further operations whenever we're trying to decide about triplets. Okay. All right. So we have a hash map here. We have a duplicate map here. Just naming them. Basically, what they do is they'll with the integer, which is the number from this, okay, which is the number from this right here, which is the number from this. We store it right here, okay, and then here we're going to store the indices, okay, and same we're going to do for the duplicate map. But let's move forward. Array list, this is the list that we're going to return because this is the requirement of the method. They want it like this. So the same data type we initialized an array list with the name main list. Okay. All right. Hash set I'm using because once I have an array, what I have an array of subarrays, right? Once I have this, I want to make sure that I don't have duplicate subarrays, right? How we do that is in hash, before I use this hash set, each subarray, I convert this to a string, okay? And before I add that to to my main list right here, I check if it's not already been added to the hash set. And once we get to this step, it's going to make sense. Okay. Now I'm going to loop over the entire array, and I'm going to first, what I do is I just build my hash maps. Okay. I build my hash maps, and okay. So if you see here, you're going to see something that you may not have come across. Okay, this is known as lambda function. Basically, what this is doing is it's taking the unique map where I want to store unique values. Okay, it's going to compute is if absent. If a value has not already been added, then let's say -1 is right now, unique map is empty. Okay, unique map is empty. Right now, there's nothing in it. This function will, if there isn't, this value existing, it will take this value and put it in the key, and then it will initialize an array, just like I told you. Okay, and add the index to it, which is dot add I. If it already exists, then it's going to return the list, the existing list, okay, and then add the second index that we have found, the same number at 0, 1, 2, 3, 4. So at first iteration, when I found -1, it added 0. In the second iteration, it will add 4. But it will make sure that we are not losing the data completely. At least we'll have indices, okay? All right, so that's the only purpose of this unique map. All right, now how are we going to use this array? If this array, where I've stored the indices, if the size is only 1, that means the number has only occurred once. If the size is more than 1, that means we have duplicates, or we have even more than that. That is where we use our duplicate map. We get our unique map, we get the value for each index I, okay? And while we're doing that, and we check if the size of this array, unique map.get value means get the value at that index, and check if the size of that array is more than 1. If it is, then we store that in the duplicate map and store along with that actual value. Okay, and that's where we map it, unique map.get value. So from unique map, we're going to get the actual value as well. So we are just mapping them just like that. All right. Now, what if you have a case like we discussed about these zeros? If we have zeros, just like in this case, we have unique, we have zeros like this. We're going to apply the same logic. We just want to return these 3 zeros. Okay. But for that, we have to check some conditions. First of all, we know that the unique map, the hash maps do not store any duplicates by default. Okay. So when we try to store all these zeros, eventually the best my hash map can do is store 1 0. But we have 2 maps, right? And we're applying the same logic back there. So unique map will end up having 1 0, duplicate will end up having 1 0, okay? And then we need to check if what we have in these 2 maps, or in the unique map at least, we don't need to check duplicate map because duplicate map only results out of this one. So if we have 0 as the key, and the size is only 1, that means we have all zeros, right? Okay. And then we can use the array list that's being initiated in the unique map to see if the size of that list inside that 0, we get the 0, and then there's a list that we're storing indices. If the size of that list is greater than 0 or equal to 0, we, in the main list, we append just this, and this will be our answer that we return as the main list. What if you have 4 zeros? Even in that case, it doesn't really matter, even if you have 1,000 zeros, right? Because no matter what we do, how we add it, we're always going to get zeros. So the best answer for us can be returning this 0th array. But you might be thinking, why not return like this? We can have multiple. Well, that doesn't really make any sense because we don't want to have any duplicates in the triplets, right? So that is the reason why we only return this answer by appending in the main list. Arrays as list mean you can get that array inside that hash map and convert that into a list and add it to the main list and return it. Okay. Now comes, what if we don't have zeros? Then we go our normal route. Okay. In that case, what we do is we initialize our I we store it in a numify. We initialize our j, where j is equal to I plus 1. By this, we mean that anytime my I is here, my j should start here. If my I moves here, my j will be starting from here and j will go all the way to the end. That is the only meaning of this logic, this part of the logic. Okay. Now, as I say that once you have computed the sum, num of I and num of j, when you have computed the sum, you want to seek the negative of that sum, right? So I'll just name it required. Integer can store the negative numbers as well to a large extent. And now we need to look for required, okay? Where do we need to look for required? We need to look at inside the maps, right? If you remember, I said I can go I and j with nested loop on this array, but when I want to access the negative number of the sum, then I need to do off one operation and get it from the hash map, okay? And that's what I'm going to do. Now is my turn that I have generated hash maps. Now is my turn to keep seeking the negative. And as soon as as I keep finding the negatives, I will keep adding that to the main list. All right, so if I find the required, what required is what the negative sum. If I'm finding the negative sum, right, this negative sum is basically mapped to a list in the unique map. If it is, then on each index, I want to loop and find out what? Okay, if the indices here in this array are not duplicated, in that case, I can create my uh, I, j, and k. Okay, this is a little bit clumsy. All I'm looking for is the required element. Okay, I found my I and j. I found my negative sum. All I'm trying to see is that does that negative sum appear at any of these indices twice? If it does not, then we have found a third distinct element. That is the logic behind it. K has to be the third distinct element. So if the K never repeated itself, that means we have found the third distinct element. Okay. So if at the same time, how do we make sure that happens is if the K is not equal to I and K is not equal to J, right? The ones that we added right here, then in that case, I found the correct K. Get required. When I get that, I check if the index of K is not equal to I and it's not equal to J. But yes, if I don't have these duplicates, if I had duplicates, then in that case, yes, okay. If K does not appear, if the indices that K has, if none of these indices are neither I or either J, then in that case, I have truly found the third distinct element because K can appear 1,000 times, right? It can appear many, many times. But my idea is like, if it appears only one times and this is not equal to I and J, then I'm good. If it appears 1,000 times, none of these indices, and how do I find any of these indices? I actually loop over them. If none of these indices are actually equal to I, either I or K, I or J, then in that case, I've truly found my third distinct element, that is the negative sum that will compute it to 0. Okay. Yes, that is the logic behind it. So then what I do, as I found these conditions are true, I can disregard this section, okay? And now let's focus on this one. I found my I, J, and K. All I need to do is initialize a list integer and add this I, J, and the nums index K, okay? The unique index. And then I do collections.sort. What this does is it gets rid of duplicate triplets. How does that make sense? Is that if you have, again, I'll repeat this, -1, -1, and 2, okay, -1, 0, and 1, okay? That is fine. These two are distinct. But what if I have 2, -1, -1? These two are same. So I don't want to have these duplicates. So this collection.sort, what it will do is it will get rid of these duplicates. I'll make sure that it's getting sorted in that manner. Finally, what I do is I do string key equal to anytime I'm computing a sublist. Okay. And I'm computing a sublist. After making sure that I'm not duplicating the triplets, I I convert it to a string and check if scene, which is my hash set will never allow duplicates. Okay. If my hash set does not contain the same already, if it's a distinct triplet, then only if the signature has not, for example, this is the triplet that I've computed, -1, -1, -2. If I convert this to a string instead, right? Hash set I can directly get if this already exists. If this already exists somewhere, if I mistakenly added twice of this, then in that case, I can disregard the second one. I will only add this one. Okay, but what was the meaning of sort? It was what if these elements inside that appear different but are same, these will get sorted. Either one of them will get picked up. Okay, so we're doing two kind of sort. First of all, we don't want to have inside jumbled up numbers looking different but they're same. Collection.sort is taking care of that. Secondly, I don't want actual duplicates, which is they look the same, but they have appeared twice somehow. Okay, so if it does not contain the key, if it does not contain the converted string already, then in the main list, you can add this sublist, this right here, not the converted string, but the actual sublist. So we're just basically creating a signature, string signature, and just comparing based off of that. And then just we keep adding the key. Key is the strings. We keep adding that. Next time when it comes here, it's going to see when it's going to generate a new key. It's going to again look in the hash set whether the key exists or not. If that key, which is the string, exists, then it will discard it. If not, then it will keep going with its normal flow. Okay, and it will break. It will not do anything. It will just go back to this seeking out another alternative. And finally, we return our main list. Return our main list. Okay, I just realized I made a mistake trying to explain this. Basically, when you have a number which is mapped to an array list 0, 1, 2, and you're trying to find k here, and you know this is the negative sum, for example, okay? If I is at 5 and j is at 8, okay, and then you have, for example, 8 here as well, and then you have a 9 here. So the k should be this one that you consider. That is the only way. So you need to find, if we have distinct indices, that is the only time where we'll be able to find a k. Either it's only 1, or even if it's 3 or 4 or 1,000, you need to make sure you get the distinct k. And that is only possible by checking continuously for each element, whether k is not equal to I or k is not equal to j. So this is the solution for that uh, this three-sum problem. This is very clumsy, and I know this is a very naive kind of solution, even though it's hitting the offhand square time complexity, but the space complexity is very bad here. Even though it does not increase per se, but still, I would like to see the left and right pointer solution to do an of one space instead of using hash maps to compute this. So that's all from my side. Over to you guys. Thank you. Sarasat? Oh, I think he is Sir Zulfikar is here, and good to have you again. Um, anyone wants to present any question other than the one on the list, please. If you have any other easy question you want to present, make sure it's from like a random lead code problem because you want to go progress along this sheet, the 75 problems together, which means I don't want to have you solve an advanced problem. So tomorrow, if I want to prepare it, I already have an idea in mind how this needs to be solved. So I won't be able to do justice with that problem. And these are really good questions. I rather do this, attempt these on my own first, and then move forward. Uh, finding anything.
सर मैं प्रेजेंट कर दूं इजी सा प्रॉब्लम है
अगर इस लिस्ट में से नहीं है तो कर दें आप उसको।
सर अभी तो इसी लिस्ट में से है
कौन सा प्रॉब्लम है?
मिडल ऑफ लिंक लिस्ट
लिंक लिस्ट तो काफी आगे है, अभी तो उसको हमने टच ही नहीं किया। हम्म,
जस्ट गिव मी अ मिनट मैं देखती हूँ इस लिस्ट के बाहर कोई मुझे मिलता है तो
कोई भी इजी सा प्रॉब्लम उठा के, अगर वो सॉल्व नहीं भी हुआ तो उसको मिलकर सॉल्व कर सकते हैं।
ओके सर
अब जब तक क्वेश्चन ढूंढे, मैं यही सोच रहा था कि इसको ऑफ एन स्क्वायर से बेहतर क्यों नहीं बनाया जा सकता। और आज के दिन में, इन टुडेज डेट, देयर इज नो बेटर सोल्यूशन देन ऑफ एन स्क्वायर। उसकी रीजन ये है कि आपके पास जब इतने सारे डिफरेंट डिस्टिंक्ट नंबर्स हैं, ठीक है, आपको एटलीस्ट दो नंबर तो चाहिए। तो उन दो नंबर्स को आप कैसे लेंगे? अगर आपके पास सॉर्टेड एरे है तो उसमें चले आप कुछ ना कुछ टेक्निक लगा लेंगे, लेकिन जब आपके पास रैंडम नंबर्स हैं तो उसमें आपको हर एक नंबर के साथ चेक करना ही पड़ेगा। और उसका तरीका यही है कि आप उसमें ऑफ एंड स्क्वायर कॉम्प्लेक्सिटी को हिट करेंगे, चाहे आप फिर उसमें वाइल लूप यूज करें। क्योंकि ऐसा नहीं है कि आप लीनियरली जाके सारे के सारे एक्सप्लोर कर लें। आप यहाँ पहुंचेंगे तो इसका फिर इसके साथ अलग से, इसका इसके साथ, सो ऑन सो फोर्थ। तो ऑफ एन स्क्वायर इसकी बेस्ट एंड वर्स्ट। वर्स्ट तो क्यूब में भी हो सकती है, ठीक है, इससे ज़्यादा भी हो सकती है, लेकिन ऑफ एन स्क्वायर बेटर है इसकी। तो मैंने टेबल्स बनाने की कोशिश की कि व्हाट इफ मैं इन सारे के सारे सम्स को मैं एक टेबल की फॉर्म में स्टोर कर लूँ, यानी ये जो अरे को लूँ मैं, इसकी रोज और कॉलम्स बना लूँ, ठीक है, इनको रीअरेंज करके यहाँ पर। और फिर किसी तरीके से एक साइज 2 की स्लाइडिंग विंडो लगा के सबके ऊपर ऑफ एंड टाइम में मैं इसको गुजार के सब निकल आएंगे तो बाकी तो इजी है। बाकी ऐश मैप वाला ही अप्लाई कर सकते हैं। लेकिन स्पेस इंक्रीज करने से आपकी टाइम कॉम्प्लेक्सिटी इसलिए कम नहीं होगी क्योंकि सिर्फ आपने यहाँ पे ये किया है कि आपने दोबारा से लूप्स लगा लगा के टाइम कॉम्प्लेक्सिटी उतनी ही कर दी आपने, रोज और कॉलम्स बना के। तो आउट ऑफ क्यूरियोसिटी इसे मैं सोचता रहा कल, आज भी सोचता रहा, लेकिन फाइनली आई डोंट थिंक देयर, मे बी देयर इज, आई डोंट नो, लेकिन राइट नाउ अभी इसका कोई भी सोल्यूशन नहीं है।
I think the input size is usually the hint. अगर लीड कोड में input size is a few thousand, then it's usually the best solution is the brute force.
For this question?
No, for all of the questions, if the input size is like 2,000-3,000, something like that, then it is a brute force solution.
Okay, I didn't know that. Good to know.
सम स्क्रीन शेयर करनी है, आप स्टॉप करते।
जी।
अस्सलाम वालेकुम। हमारे पास ये प्रॉब्लम है, सर्च इन अ बाइनरी सर्च ट्री। तो इजी सा प्रॉब्लम है, आई थिंक सबको आइडिया भी होगा कि सर्च बाइनरी सर्च जो एल्गोरिदम वो क्या होता है। तो हम उसके अकॉर्डिंग इसको सॉल्व कर लेते हैं। हमारे पास एक ट्री दिया होगा, हमने इसमें सर्च करना है जो हमें टारगेट दिया होगा। हमारे पास यहाँ पे ये ट्री और इसमें हमें टारगेट 2 दिए गए। अब बाइनरी सर्च में क्या होता है, जो एल्गोरिदम है उसमें हमारे पास जो एलिमेंट्स होते हैं वो अरे में हम क्या करते हैं, वैसे बाइनरी सर्च में देखा ना जाए तो उसमें एलिमेंट्स जो हैं वो सॉर्टेड फॉर्म में होते हैं। जैसे हमारे पास ये करे है 1 2 3 4 एंड 5 तक बस करते हैं। तो अगर हमें कोई एलिमेंट फाइंड आउट करना हो तो हम सबसे पहले मिड फाइंड आउट करते हैं उस अरे का। फॉर एग्जांपल हमें मिड ये मिला और हमारा टारगेट है 1 फाइंड आउट करना। तो हम क्या करते हैं कि अगर हमारा टारगेट और मिड इक्वल होते हैं तो हम उसी को रिटर्न कर देते हैं, और अगर इक्वल नहीं होते तो फिर हम कंपेयर करते हैं क्या अगर उससे लेस है। अगर हमारा टारगेट, ये जो हमारा टारगेट 1 है ये फाइंड आउट करना, ये मिड से लेस है तो हम लेफ्ट साइड पे मूव कर जाते हैं। और अगर हमारा टारगेट जो है वो इससे ग्रेटर हो तो फिर हम राइट साइड पे मूव कर जाते हैं, क्योंकि हमें पता होता है कि एलिमेंट्स हमारे के सॉर्टेड फॉर्म में हैं। तो इस तरह हम हर आइट्रेशन के बाद जो है हाफ अरे को ट्रिवर्स करे होते हैं। तो हमारे पास जो बाकी हाफ है वो ट्रिवर्स नहीं होती, तो वो हमारी कॉम्प्लेक्सिटी जो है वो n से log n में चली जाती है। सेम इज द केस हेयर, जहाँ पे हम बाइनरी सर्च ट्री को ट्रेवर्स करेंगे। बाइनरी सर्च ट्री में कंडीशन हमारे पास ये होती है कि इसमें जो हमारा ट्री होता है वो ऐसे बना होता है कि जो रूट नोड होते हैं उसके लेफ्ट साइड पे स्मॉलर एलिमेंट्स होते हैं, और उसका जो राइट चाइल्ड होता है वो हमेशा उससे ग्रेटर होता है। और यहाँ देखें तो 4 से 2 स्मॉलर तो ये इधर है और ग्रेटर एलिमेंट इधर है। और इसी तरह अगर 2 के बाद 2 जब रूट बनेगा तो इसके भी लेफ्ट साइड पे स्मॉलर एलिमेंट्स होंगे और राइट साइड पे ग्रेटर एलिमेंट्स होंगे। सो इसको यूज़ करके जो है हम बाइनरी सर्च को ही यूज़ करके हम इसमें सर्चिंग करेंगे। हमारे पास एलिमेंट जब आएगा जिसे हमने सर्च करना होगा उसे हम रूट से कंपेयर करेंगे। अगर वो रूट के इक्वल होगा तो हम सिंपली रूट को ही रिटर्न कर देंगे, और अगर वो रूट से ग्रेटर होगा तो हम राइट साइड पे रूट की मूव कर जाएंगे, और अगर वो रूट से लेस हुआ तो हम उसकी लेफ्ट साइड पे मूव कर जाएंगे। और आगे फिर नेक्स्ट रूट से कंपेयर होगा, फिर अगर वो उस रूट के इक्वल होगा तो वो रिटर्न हो जाएगा, अदरवाइज उससे कंपेयर होके लेफ्ट साइड हमने ट्रेवर्स करनी है राइट वो हम डिसाइड करेंगे। तो यहाँ हमारे पास जैसे कि 2 हमने फाइंड आउट करना है, तो जब हम यहाँ कंपेयर करेंगे 4 से तो हमारा ये स्मॉलर एलिमेंट है 4 से, तो हम लेफ्ट साइड पे लेफ्ट सब ट्री पे मूव करेंगे, और लेफ्ट सब ट्री पे जाके हम इस रूट से जब कंपेयर करेंगे तो अगर तो इसके इक्वल है तो हम इसको सिंपली क्योंकि यहाँ हमारा ये इसके इक्वल है तो हम इसको रिटर्न करें। और जब इसको 2 को रिटर्न करेंगे तो इसके चाइल्ड भी ऑफ कोर्स इसके साथ आएंगे कि वो इसके साथ कनेक्टेड है। सो हमारे पास रिजल्ट जो है वो 2 1 3 आ जाएगा। हम नेक्स्ट एग्जांपल्स को भी देख लेते हैं, क्योंकि कुछ बेस केसेस भी होते हैं कि अगर हमारे पास हमारी रूट एम्प्टी हो तो उस केस में क्या होता है। अब इस केस में देखिए वैल्यू 5 फाइंड आउट करनी है। अब 5 जो है वो मिल ही नहीं रही, इस ट्री में है ही नहीं। तो जब हम सारे ट्री को ट्रेवर्स कर लेंगे और हमें वैल्यू फिर भी नहीं मिलेगी तो हम एम्प्टी रो जो एम्प्टी रूट रिटर्न करवा देंगे। और इसी तरह एक और केस है, दिया हुआ तो नहीं है लेकिन अगर तो रूट है या एम्प्टी, तो ऑफ कोर्स फिर भी हम जो है एम्प्टी जो लिस्ट है रिटर्न करवा देंगे। और कुछ कॉन्स्ट्रेंट्स हैं कि नंबर ऑफ नोड्स कितने हो सकते हैं, 1 से 5000, और वैल्यूज 10 इन रेज टू पावर 7 तक हो सकती हैं। और बाइनरी सर्च ट्री है, और आगे फिर वैल्यूज का ही बताया हुआ है। क्वेश्चन क्लियर है सबको? बहुत इजी से क्वेश्चन क्लियर है, तो हम सॉल्यूशन की तरफ मूव करते हैं। चैट में क्वेश्चन। ओके ओके सर, हम क्या करेंगे, हम रूट को ट्रेवर्स करेंगे वाइल रूट, जब तक रूट हमारे पास है। इफ रूट डॉट वैल, जो रूट की वैल्यू है वो इक्वल है हमारी वैल्यू जिसे हम सर्च करना चाह रहे हैं, तो हम सिंपली रिटर्न करवा देंगे रूट को। अगर ऐसा नहीं है एलिफ, फिर हम कंपैरिजन करेंगे कि रूट डॉट वैल जो है वो, अगर तो वो ग्रेटर है जो हमें वैल्यू फाइंड आउट करनी है, तो फिर हम क्या करेंगे, रिटर्न। अब हम यहाँ पे ना यूज करेंगे रिकरियन को। हम रिकर्सिवली जो है ट्री का लेफ्ट और राइट सब ट्रीज को रिवर्स करेंगे। रिटर्न सेल्फ डॉट, हमारा जो फंक्शन का नाम है, और इसमें हम रूट डॉट, क्योंकि हमारी जो रूट की वैल्यू है वो ग्रेटर है और जो हमें फाइंड आउट करनी है वो लेसर है, तो वो ऑफ कोर्स इसकी लेफ्ट साइड पे होगी। तो हम यहाँ पे फिर इसको लेफ्ट सब ट्री देंगे ट्रेवर्स करने के लिए, और साथ में वैल्यू भी देंगे, क्योंकि हमारा जो फंक्शन है ना, इसमें भी हमें दो पैरामीटर्स पास करने हैं। एक वैल्यू, क्योंकि नेक्स्ट टाइम पे भी तो कंपैरिजन होना, जब यहाँ वैल्यू आएगी इधर इस जगह आएगा लेफ्ट सब ट्री, और यहाँ पे तो वैल्यू ने कंपेयर होना है, तो हम दोबारा वैल्यू को देंगे। एलिफ अगर ऐसा नहीं है, ऑफ कोर्स वो केस होगा जिसमें जो रूट डॉट वैल होगी वो लेस होगी वैल्यू से, तो फिर हम राइट साइड पे मूव कर जाएंगे। एल्स में क्या होगा कि ये वो केस है जब हमारे पास एलिमेंट मिलेगा ही नहीं, तो जब एलिमेंट नहीं होगा हमारी अरे में जो हम फाइंड आउट करना चाहते हैं, तो हम सिंपली जो है वो नल रिटर्न करवा देंगे। ओके, रन करने का ऑप्शन क्यों नहीं आ रहा? ओके ये सो ये हमारा जो है रन भी हो रहा है और हमारा सबमिट भी हो रहा है। ओके, क्वेश्चन का सॉल्यूशन क्लियर है सबको, या हम ट्राई रन कर लें अगर कोई चाहते हैं? रिकरियन का सबको पता है, रिकरियन काम कैसे करती है? किसी को आइडिया ना हो? कोई तो रिस्पॉन्स दे दें।
रिकर्जन बेसिकली यही है ना कि आप फंक्शन फंक्शन अपने आप को कॉल करता रहता है जब
यस
तक बेस कंडीशन को ना मीट कर जाए। तो आपकी हर एक रिकर्सिव कॉल एक स्टैक मेमोरी के अंदर स्टोर होती है, और स्टोर होती होती है, और जैसे ही वो बेस कंडीशन मीट होती है तो उसके बाद स्टैक अनवाइंड होती है। तो जो आपके पास लास्ट एलिमेंट जो स्टैक का होता है उस पर जो स्टोर हुआ होता है वो रिटर्न होना शुरू होता है, और स्टैक अनवाइंड हो जाती है, यानी कि वापस आके जीरो हो जाती है स्टैक, और वो आंसर हमारे पास रिटर्न हो जाता है। तो
यस
इसको ज़रा बताइएगा मुझे, पाइथन से मैं यूज़ तो नहीं हूँ, या आपने यहाँ पे रिकर्जन ही यूज़ किया ना?
यस सर।
अच्छा, तो आपने सर्च बाइनरी ट्री में इनपुट दिए रूट डॉट लेफ्ट को, और वैल्यू आपने दी है। अच्छा,
ये
और कंडीशन क्या है कि जब तक आपकी जो रूट वैल्यू है वो वैल्यू से बड़ी है, टारगेट से जब तक बड़ी है, तो तब तक आप उसको रिकर्स करते रहे। कौन से वाले को? लेफ्ट वाले को। ठीक है, ऐसा ही है।
यस सर।
अच्छा, तो हमने उससे छोटे नंबर, क्योंकि अभी बिल्कुल हाँ मेक सेंस, क्योंकि हमने हमारा टारगेट नंबर छोटा है, वैल्यू नंबर छोटी है, ऐसे ही है।
एग्जैक्टली सर।
अच्छा, अगर हमारे पास रूट की जो वैल्यू है वो कम हो जाती है, तो देन हम क्या करते हैं कि हम उससे बाहर, उस रिकर्जन से बाहर आ जाते हैं।
नहीं सर, राइट साइड पे चले जाते हैं ना।
राइट
अगर
साइड पे
रूट
जो,
की
अच्छा अच्छा।
जी, फिर राइट साइड पे ट्रेवर्स करेंगे, सर्च करेंगे।
अच्छा, तो जहाँ पे मेरे पास अगर लेफ्ट साइड पे मुझे 7 मिल जाता और राइट साइड पे मेरे पास 2 1 3 होता, तो मैंने फिर राइट साइड पे स्विच कर जाना था। क्योंकि अब
राइट
7
क्या
फिर 4 से
करें?
बड़ा है ना।
यस सर।
हम्म।
हमें हमेशा ट्री की एक साइड ही सर्च करनी पड़ेगी, क्योंकि बाइनरी सर्च ट्री है तो हम रूट से कंपेयर करते जाएंगे और हमें पता चलता जाएगा कि हमने लेफ्ट में जाना है या राइट में जाना है।
अच्छा, तो लेफ्ट पे जाना हम कब रोकते हैं? कि जब हमारे पास जो पेरेंट नोड है उससे अगला नंबर बड़ा आ रहा है। जैसे अब 2 से
सर
1 पे। जी,
जी जी सर, आप क्या कह रहे हैं?
मैं कह रहा हूँ 2 से जब हम 1 पे आते हैं तो
यस
हम
सर।
कंटिन्यू करेंगे अगर हमारे पास मजीद नोड्स भी होते हैं।
यस सर। और वो उस बेस पे कंटिन्यू करेंगे ना, हम जब 2 पे आएंगे ना, इधर आके भी हम वैल्यू को कंपेयर करेंगे इसके साथ। अगर
बिल्कुल।
तो वो इसके इक्वल है तो रिटर्न हो जाएगी, अदरवाइज हम फिर कंपेयर करेंगे कि वो इससे लेस है तो हम लेफ्ट साइड पे चले जाएंगे। अगर वो इससे ग्रेटर है तो फिर हम राइट साइड पे चले जाएंगे।
ग्रेटर है तो राइट साइड पे चले जाएंगे, वैसे हमने लेफ्ट पे ही जाना है।
यस।
अच्छा, तो यानी अगर हमारे पास लेफ्ट पे नहीं है तो फिर हम, हमारे पास दूसरी कोई ऑप्शन नहीं है, हम राइट पे ही जाएंगे। वी आर फोर्स टू डू दैट। आप ऐसा करें, इस ट्री को बढ़ाएं ज़रा, एक एग्जाम्पल बना के दिखाएं। इतना 5 मिनट ही रह गए, और बजाय इस एग्जाम्पल के जो 2 1 3 है इसके मजीद चिल्ड्रन नोड बनाएं, और वहां भी मुझे बताएं कि 2 1 3 का चाइल्ड तो समझ में आ रहा है, लेकिन उससे मजीद 1 के बाद अगर मेरे पास बड़ा नंबर आ गया और टारगेट मेरा लेट्स से 0 है।
कि सर टारगेट 0 है, और ये जो बाइनरी सर्च ट्री है तो 1 के बाद वो प्लेस ही नहीं होगा। फॉर एग्जांपल अगर यहाँ पर 3 के आप अरे को एक्सटेंड कर लें जो हमारे पर लिस्ट ओरिजिनल दी हुई है, कौन सा एलिमेंट सर ऐड करना चाहते हैं, हम इसमें ऐड करते हैं।
अच्छा, फिर ऐसा करते हैं, जो 2 वाला ना इसको 3 कर देते हैं, 1 को 2 कर देते हैं, और 1 के बाद फिर हम 1 फिर जहाँ पे हमने 2 लगाया उसके बाद एक 1 नोड बना देते हैं।
तो यहाँ पे 2
जी,
और यहाँ पर
यहाँ पे कर लेते हैं, यहाँ पे 1 लगा। टारगेट हमारा क्या है? यहाँ पे एक छोटा नंबर लगा लें, ठीक है, यहाँ पे कोई छोटा नंबर 2 लगा दें यहाँ पे, या 2 लगा दें।
सर जब बाइन ये देखिए हमारे पास ना इस फॉर्म में एलिमेंट आते हैं, तो जब इसका ट्री बनता है ना, तो
जी।
जब हम ट्री बनाना शुरू करते हैं हम उसको बनाते ही ऐसे हैं कि वो कंडीशंस को सेटिस्फाई करे। अब यहाँ पर अगर हम यहाँ पर 2 रख देंगे ना तो वो इस कंडीशन को वायलेट कर रहा होगा जो बाइनरी सर्च ट्री है, क्योंकि बाइनरी सर्च ट्री में हमेशा जो राइट चाइल्ड होता है वो अपने पेरेंट से ग्रेटर होता है।
अच्छा, राइट
जी।
साइड हमेशा अपने पेरेंट्स से
तो
ग्रेटर।
सर आप लिस्ट चेंज करवा दें, जब लिस्ट चेंज हो जाएगी तो फिर हम ट्री दोबारा से ट्री बना लेंगे और फिर आपको शायद क्लियर हो जाए।
ठीक है, आप अपनी मर्जी से इसको मॉडिफाई करें, देखिए आपको बेटर एग्जांपल क्या आती है। मुझे भी इसको टाइम लगेगा इसको समझने में, से मैंने कभी नहीं इस कॉन्सेप्ट को स्टडी किया।
ओके।
बहरहाल हमारे पास 3 मिनट रह गए हैं, तो अगर ज़्यादा टाइम चाहिए तो इंशाल्लाह कल भी कर सकते हैं इसको।
तो सर ये बहुत सिंपल है, इसके अलावा चाहते हैं कि आप कोई और एग्जांपल लें?
हम्म,
सेम एग्जांपल नीचे भी दी हुई है।